In 2012, a spacecraft operating over 15 billion miles away from Earth hit something out in the dark. This graph shows the data sent back by Voyager 1's instruments. For decades, the surrounding particle density reading was a flat line. Then, suddenly, it spiked by a factor of 40. The probe had driven straight into a barrier of highly compressed plasma. By pushing through it, Voyager became the first human-made object to taste the material of interstellar space. When its twin, Voyager 2, passed through that exact same region 6 years later, the readings matched. The wall was physically there. That violent spike in data replaced the image of a gentle solar fade with a dense, turbulent wall of plasma. Headlines around the world announced that Voyager had successfully left the solar system. But physically speaking, it hasn't. This timeline illustrates the actual scale of its exit path. Voyager has been flying for nearly 50 years. It will take another 30,000 years of travel for it to truly exit our solar system. If a probe can measure the cold gas between stars while still being trapped inside our local system, we have to look closely at what exact boundary it actually pierced in 2012. The origin of that plasma wall sits right at the center of our map. The sun's solar wind creates the heliosphere, a massive bubble protecting the planets. Billions of miles out, this wind loses momentum and collides with cold interstellar gas. The plasma compresses into a dense shell called the heliopause. This is the physical barrier Voyager crashed into. On the other side of that shell, the warm solar wind vanishes completely, replaced instantly by freezing interstellar gas. Piercing that wall meant Voyager had exited the sun's weather system. It is swimming in interstellar space, but it still remains well within the sun's reach. There is a second, much larger boundary defining our home, governed entirely by gravity. This diagram reveals the Oort cloud, a colossal shell of icy comets held by the sun's gravity. Even traveling 38,000 miles per hour, Voyager won't reach its inner edge for 300 years. It will spend another 30,000 years drifting through it before breaking free. Gravity commands a territory far larger than the solar wind. A spacecraft can easily float in the interstellar medium while remaining entirely bound to our star. The solar system ends in a broad transition zone where the sun's zone slowly dissolves over trillions of miles. This space is a series of overlapping boundaries dictated by separate physical forces: magnetic weather, compressed plasma, and gravitational grip. These fading layers of influence stretch outward, extending almost halfway to the nearest neighboring star. Humanity's first step out of the solar system is a slow 30,000-year wade through the outer ghosts of the sun's territory. Today, Voyager 1 drifts deep within this transition zone, over 15 billion miles away. Its power reserves are steadily dropping. Within a few years, its remaining instruments will power down for good, leaving the probe to coast in total silence. Even in that silence, bolted to its frame is the Golden Record, a literal time capsule containing the sounds and images of Earth. Long after we are gone, this tiny, quiet machine will continue mapping the scale of our cosmic home, layer by layer, out into the dark.